In the last segment, we saw that the location of the electron has to do with the shapes, which are given symbols S, P, D, and F, and that within those shapes, they can reside in various n levels. So segment 7 begins here. How does any of this help us? Well, we need to assign electrons a home or an orbital. They are assigned according to very prescriptive rules that are beyond the scope of anything we can talk about in this class. However, the upshot is that there is an order to how the orbitals and therefore the sublevels are filled, just like there are rules for a Monopoly game. And the rules are the rules. We don't need to explain them. We simply say they are the rules. Okay, so in Monopoly, you start with low value properties and you land on certain spaces, and as you go around the board, the value increases. So for example, in the game of Monopoly, there are only certain places we can put our game pieces and certain places that we can move around the board that increases in value, which is analogous to saying increase in energy. There is an order and there are rules. Okay, so happily for us, the rules figure all this out for us and we just go along with it. Okay, so the order in which the orbitals or sublevels are filled are as such. The order is the order and it never changes. 1s has to be filled first, 2s, then 2p. Remember, there's 3 opportunities in 2p. 3s, 3p, 3 opportunities within that. 4s, 3d. Remember, there are 5 opportunities within 3d. 4p, 5s, etc., etc. That never changes. Okay, so what we have is I could make a Bohr model, protons and neutrons. N equals 1, I'm allowed to have a 1s. That means I can put 2 electrons there. Once I have more than 2 electrons, I can't be in N equals 1 anymore. Then I have to go to N equals 2. There I'll find a 2s, and I'll find an orbital that I can put 2 electrons in. Then my choices are 2p, and there are 1, 2, 3 opportunities to be in a 2p. Remember, they can go x, y, or z. Okay? So 2 electrons can go here, 2 electrons can go here, 2 electrons can go here. Once I'm done filling those up, I have no more space in N equals 2. So then I can go to N equals 3. 3s, I can put 2 electrons there. 3p, I can put 2 electrons, 2 electrons, 2 electrons, or up to 6 electrons in 3p. Then, if the order allows me to do so, well, after 3p, where I have to go is 4s. So 4s then means I come over here to N equals 4, and I have a 4s. Okay? Now, I don't make this up. This is Albert Einstein and his wife and a bunch of other very smart physicists. But after I fill in 4s, I have to go back to 3d. Okay? So 3d, I have 1, 2, 3, 4, 5 orbitals that I can put electrons in 3d. So 2 electrons, 2 electrons, 2 electrons, 2 electrons, 2 electrons. And I keep building. Okay? So when N equals 1, I have 2 electrons max. 1, 2. When N equals 2, I have 2, 4, 6, 8 electrons max. When N equals 3, 2, 4, 6, 8, 10, 12, 14, 16, 18 electrons max. But I have to come out to 4s before I come back to 3d, and so forth. And I keep building this way. 2n squared gives us our maximum per n level. So when n equals 4, 4 times 4 is 16 times 2 is 32 electrons max in theory. N equals 5. 5 times 5 is 25 times 2 is 50 electrons max, and so forth. So you can see we end up, when the n levels get higher, we have, let's see, 80, 100, and 108 electrons, and we haven't even gone up to n equals 7. So you start to see why n equals 7 is our highest n level. We just don't have enough electrons to even put there. Okay? All right. Again, magnetic spin, m sub s, shows that we can have 2 electrons max per orbital. And so I've written 2 electrons in each orbital, but really it has to do with what we call magnetic spin. And this can easily be shown by the right-hand rule. Okay, so when the electrons are rotating counterclockwise, my thumb is pointing up. So we can show our electrons with magnetic spin pointing up, okay, counterclockwise. Or I turn my hand this way. It's kind of hard to do with my little studio at home, but, right? So now I'm going clockwise, and you can see my thumb is pointing down. So usually and typically, instead of writing 2, 2, 2, 2, 2, 2, 2, you'll show your electrons as spinning up or spinning down. Okay, so 1s, spin up, spin down. 2s, spin up, spin down. 2p, I don't make up the rule, but the rule says we have to spin up, spin up, spin up, spin down, spin down, spin down. Spin up, spin down, up, 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 down, 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 and so forth. And you can fill out this entire chart. As long as you have electrons, that's the order in which they fill those areas or orbitals. Okay? Up, 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 down, 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 down. There are some rules, and we're kind of skipping some of them. The Aufbau principle, the Pauli exclusion principle, Hund's rule. Okay, so this is the order, and all you have to do to figure this out is to keep building. We go back to our Bohr model. We show these. Again, I can draw this again, and I would encourage you to do that. But have your electrons spin up, spin down. Okay, so try again. Except in each of your boxes, spin up, spin down. Okay? The next segment will begin on page 11.